Bismillahirrahmanirrahim. So number 11, okay. If an object is allowed to fall from a height of 60 meters, where will be its potential energy, half of its kinetic energy? This type of problem actually we solve in SSC level, that our object is allowed to fall from this height, which is 60 meters. Okay. Now let us say our desired condition, that is the potential energy is half of its kinetic energy. Potential energy is half of its kinetic energy. This is the situation. Now we don't know at what height this situation will occur. Let us say at x height from the ground, the situation occurs. Okay. So if the total height is 60 and this is x, then can you tell me what will be this height?
60 minus
60 minus x.
60 minus x. Very good. So we have considered that at position, let us say this is B and this is position A. Okay. So at position B, our desired situation occurs. Now, what for position B, okay, we are interested in position B. This line is for a position B. Now, what is the potential energy at position B? That will be mgx, right? Because mg into the height from the ground. Height from the ground is x. And half into the kinetic energy. Kinetic energy is half mv square. Now we do not know the velocity. So we need to do the calculation of this velocity in some other way. If you remember, we do it in this way, v square equal to v naught square plus 2g into the covered distance, okay? What distance I will write here, that is the covered distance, not the height from the ground. This I tell you repeatedly, okay, whenever I'm teaching this topic, okay? So the body was at this position, now it is at this position. So what is the distance that it has covered? 60 minus x, right? So we will put 60 minus x here. Now we always consider that it was falling from rest. So the initial velocity is 0. So if initial velocity is 0, this will become 0 and it will be 2g into 60 minus x. Now let us replace those values over here. Okay, from both sides actually I can cancel m and m. Okay, if I divide both sides by m, then it will be gone. Here it will be gx is equal to 1 by 4 into v square will be replaced by this 2g into 60 minus x. Now 2, if I cancel it will be 2 here and both sides divided by g, right? So I have x, I want to find the value of x only. So I can do that now. It will be 60 minus x divided by 2. So 2, it will be cross multiplied, 2x minus x. If I change the side, it will become plus x and it will be 60. So 3x will be equal to 60 and x will be equal to 60 divided by 3 equal to 20 meter. So we can say that at 20 meter height from the ground, our desired situation will occur. Clear?
Yes.
Did I go too fast? Sadia asked this out. So Sadia, did you understand?
No, yes,
Oh, yes?
yes,
That's okay. So you don't have any doubt, right? Clear?
no, yes.
Okay, then number 19. In number 19, okay, we can the depth of a water-filled well is 10 meter and its diameter is 1.5 meter. Okay. A pump can make the well empty within 25 minutes. Okay. Calculate the horsepower of the pump. If a pump of 0.4 horsepower is connected, then how much time will be saved? Do you have any specific doubt here or I need to discuss the whole problem?
Whole problem.
Okay. So they have told us at first, they have to ask us to calculate the horsepower of the pump, the first pump that is there. Before attaching another one, there was a pump and what is the horsepower of that. Horsepower means power, right? So power is equal to work done divided by time. Now, as we are moving a certain amount of water, okay, that water will have a certain amount of weight and there is a certain amount of displacement that is taking place, right? So mgh by t. Now, if you notice, the mass of the water is not given. Okay, mass of water is not given, but that cannot stop us because we can calculate it from some other value, m, right? If I cross multiply, then it will be rho v. Now, rho of water is something that we already know. It is 1000 kilogram per meter cube. Now, what is the volume of the water? Now, as I have kept the water in a well, okay, and the well is a cylindrical shape, right? A well is something cylindrical. So if I can calculate the volume of the well, I can say that that amount of water I have kept here, okay? Volume is something that tells us how much space is there inside something, okay? So how much ever space is there, only that amount of water we can keep, right? So if I can calculate the volume of the well, I can tell that is the volume of the water. Equal amount of volume of water I have kept there. I can say this. So what will be the volume of the cylinder? The formula to calculate is pi r square L, right? Here you can replace the value of r. They have given the diameter 1.5. So if you divide diameter 1.5 by 2, then you will get the radius. That will be 0.75 meter. Okay, so replace the value of r here and height. Oh, the depth of the well, that is given as 10 meter, right? L is 10 meter. This is given directly as 10 meter. So from here, we can actually calculate the mass, right? So we will put the value of mass over here. We know the value of G, that is 9.8. And the interesting part is this height. I already told you, whenever we're talking about emptying a well or filling up a tank, okay, the effective height that we will have to take, that is the half height of the tank. Okay, so it is going to be 5 meters. The value of H will be 5 meters. And what about the time? Is the time given? Yeah, it gets emptied within 25 minutes. So it will be 25 into 60 seconds. Okay, so yeah, as it appears, we know the value of all the things over here. Okay, so if you put all the values, you will be getting your answer. I will take the answer from here directly itself. It is 556.975, 556.975 watt. Now the thing is, we are not done yet because they have asked us what is the horsepower. Okay, the unit needs to be in horsepower. We have calculated it in watt. Okay, so if I want to convert it into horsepower, I need to divide it by 746. As I already told you in the last class, that 1 horsepower is equal to 746 watt. So if you divide it, you will get your answer in horsepower. That is the answer of the first part, okay? Can I move to the second question? Yes or no? One answer should be there.
Yes.
Okay. So the next question.
Sadia.
Huh?
Sadia Butcho.
Sadia?
Yes,
right?
Yes, sir.
Okay. So if a pump of 4.4 horsepower is connected, then how much time will be saved? Yes, we can understand this. Now we previously there was one motor. Okay, now we are adding another motor. So when two motor will work together, they will finish the work in less amount of time. We can understand this through this analogy that if one person is doing some work in 10 days, if I employ another work, okay, 2% definitely will finish the work sooner. Some time will be saved, right? So in this case also, we are increasing the number of motors. So as a result, what will happen? The time will be saved. How much time will be needed? So we need to calculate time t now, okay? Achha. So again, we will write P is equal to W by T. Now, if you notice, the power will be, now combined power of the two motor. Number one, let us say that is P1, that is the that is P1 that we calculated a little bit ago. Okay, that is the power of the existing motor. Now we are adding another motor, okay, of 0.4 horsepower. You have to actually convert that, P2 is equal to 0.4 horsepower. You have to convert it into kilowatt by multiplying 746. Okay, so you will get it in watt. Okay, so P1 already we knew the value in watt. P2 also I showed you how to calculate it in watt. And work done, this will remain same, mgh. Okay, I'm doing the same amount of work. Now that what will happen? The time, let us say the time is t prime now. Okay, the new time, the previous time was t, which was 25 minutes. Now the new time I need to calculate t prime. So in this equation, you will see that other than t prime, all other parameters are known to you. So you can calculate the value of t prime. Okay. Can you
sir workটা calculate করেন?
ওয়ার্কটা ক্যালকুলেট করব? ওয়ার্কটা তো এর আগে আমি ক্যালকুলেট করছিলাম যে ওইটার মতো।
কিন্তু ওইখানে যে ওয়ার্কটা দিছিল এখানে পাওয়ার 5 কেন দিছে?
পাওয়ার 5 কেন দিছে কোথায়?
10 into দেখেন 10 into 10 to the raised to the power 5 kilogram per volume.
Oh, definitely that is a mistake. Because we are still lifting the water, right? We are still lifting the water. So the density is going to be 10 to the power 3 only. It's a mistake করছে, বুঝাই যাচ্ছে। All other things are same. 10 to the 5 10 to the 3 হবে. So correct it. Okay. Okay. So you can calculate the time t prime. That is not your final answer. They did not ask you how much time they will take now. If they asked you how much time will be needed now, then t prime is your answer. But they asked you how much time you have saved. So you have to find that out by subtracting t prime from t. This will give you the answer. Okay. Like if I tell you that the price of a shirt was 15 taka, after discount you got it with 12 taka. So how much money you saved? So what you will do, you will say me 3 taka I have saved. How did you calculate? By subtracting, right? 15 minus 12, 3 taka I have saved. Like that. Okay, previously t amount of time was needed, but now t prime amount of time is being needed. So I can say by subtracting that this much amount of time has been saved. Sadia, বুঝতে পারছো?
Yes, sir.
Acha. After that, somebody asked about 21A or B?
Sir, 22 লাগবে না।
আচ্ছা, 21
আমি doubtful.
Tariq, 21B. What is the problem?
Sir, पूरा explain করে দেন।
পুরাটা করতে হবে, ওকে? আচ্ছা।
স্যার আমারও ডাউট এটা।
ওকে।
স্যার আমারও।
এখানে ক্যালকুলেশনটা বুঝানো মনে হয়। Acha, let us go through the question first and try to understand it. An object of mass 10 kg is hung from the point O. We do not need to draw the tree. We just need to show that there is a rigid support, and from it a 10 kg mass has been hung. Now, with a string of length 10 meters. So this is 10 meters. And the object is allowed to swing freely from the point O. This is the point C, this is the point O, and I have taken it to a point A. Okay, I took it here, and from there I left it. Okay, so it is hanging after the influence of gravity on. Acha, ignore the obstruction due to friction and air. Okay, we have to ignore that. Actually, in the figure, actually there are some other information given that this angle is 60 degrees. Okay, and I can see that there is another point B in between, B, which is at a height 3.75 meter from the ground. Okay, fine. Now they have asked, will the kinetic energy at C of the stem be different than that at B? Okay, so we need to calculate the kinetic energy at C and kinetic energy at B. Let me write it here, Kc and Kb. I have represented in this way. Okay, kinetic energy at point C, kinetic energy at point B. Acha, now let us think about it in this way. Let us use our basics, okay? We know that at this point, all the energy is potential energy. There is no kinetic energy. And when it comes to this point, all the potential energy has been converted to kinetic energy, right or wrong? So will it be wrong that if I say the potential energy at point A is equal to the kinetic energy at point C?
No.
No, it will be right, right? So if I want to calculate Kc, I need to calculate UA, right? The potential energy at point A. That amount of energy will be converted completely into kinetic energy at the point C, as per our basics.
Yes.
So if I calculate UA, then obviously I can actually tell that that is the kinetic energy at point C. So now my focus is to calculate the potential energy at point A. If I want to calculate the potential energy at point A, I need to know at what height the point A is from the equilibrium level, right? Just 1 minute, it was on the chat. Okay. As you can see, I have already carried out the calculation. Could you understand while I was carrying out the calculation, what I did actually?
Yes. I'm a good student.
Okay. So as I told you, the potential energy at point A is equal to kinetic energy at point C. So let us focus on calculating the potential energy at point A. That will be mgh. H means height, right? So what is the height from the relaxed or equilibrium state? This is the equilibrium state, and the height of the point A is mc. If I draw a perpendicular from here, then the height, as I can see here, is mc, right? So the height here is mc. Now I do not know any calculation for mc, but I can find it out. Om minus om. Sorry, OC minus OM. From OC, if I subtract OM, I will get MC. So that is what I have written. And I can see M, I know, G, I know, OC is, 10 meter string, I already know, so I have written. But OM is something that I don't know. So OM I have to calculate, and for that I have drawn this OMA triangle here separately, okay? You can see that this angle is 60 degree, okay? And as this string is 10 meter, when it goes to that position, that string is still going to remain 10 meter. So OA will be 10 meter, and I need to calculate the value of OM, right? How I can do that? This 60 degree, for this 60 degree, I know the hypotenuse. 90 degree opposite, this is hypotenuse, and this is adjacent that I have to find out. So adjacent and hypotenuse tells us to take the trigonometric ratio cos, right? So cos 60, I will find the value of OM from here. And if I put the value of OM over here, then I can easily calculate the potential energy at point A, and subsequently Kc, kinetic energy at point C. Now it is clear, Sadia, Tariq? And
Yes.
okay, so I have calculated the kinetic energy at point C. Now I can calculate the kinetic energy that will be at point B. Okay, that will be my target. Okay, now we got to know the potential energy over here is 492 joule. If I want, I can calculate the potential energy at point B also, right? Let us calculate the potential energy at point B. It will be mg, and the height from the equilibrium level is 3.75, as you can see. So 10 into 9.8 into 3.75. Somebody get ready with calculator and do the calculation and let me know the answer.
Three 36750.
36750.
50.
Are you sure?
Sir, 367.5.
367.
367.5.
367.5, right? Okay. Then this joule. Okay. Now let us think about it. At position A, the potential energy was 492 joule. At position B, it is 367.5 joule. There has been a decrease of potential energy, right? Now we know that an amount of decreased potential energy is equal to the kinetic energy, right? How much kinetic energy,
Yes.
how much potential energy has been converted into kinetic energy. So if I want to calculate KB, kinetic energy at this point, I can just calculate the decrease in potential energy. 492 minus 367.5. If anybody have any doubt that why I'm doing this, then let me know, please, now. Very easy to understand. I can explain again, no problem. Did you understand why I subtracted this?
Yeah.
Okay, যতটুকু potential
Yes.
energy কমবে সেটাই kinetic energy তে convert হয়ে গেছে বলে potential energy যতটুকু কমে গেছে। So তাহলে you subtract it and you will get a certain value. And they have asked whether these two are same or not. We know that they are not going to be the same, right? So we can just tell that okay, they will be different. Okay, clear?
Yes.
Yeah.
Sadia, Tariq.
Yes, sir.
Yes.
Okay, and others also please try to respond. Okay, you are not messaging me any doubts, you are not asking me any questions. I don't know what is the problem. Actually, I do know what is the problem. Lack of interest. But I don't know what else I can do. I'm trying to represent all the things in much easier way to you, but I think it's not easy enough for some of you. That's okay. Then did somebody ask about 22?
Sir, 22 now.
Then which one? 23. Lamia asked about 23A, right?
Lamia Tariq দুজন।
আচ্ছা 23A এখানে 23 এর যে ইকুয়েশনটা আমি দেখতেছি সেই ইকুয়েশনটা আসলে আমরা এখনো পড়ি নাই। এটা আমরা পড়বো কোন চ্যাপ্টারে জানো? তোমাদের চ্যাপ্টার 8 মোস্ট প্রবাবলি পিরিয়ডিক মোশনের, দেখো তো। হ্যাঁ, চ্যাপ্টার 8 পিরিয়ডিক মোশন। এই চ্যাপ্টারে আসলে আমরা এই ইকুয়েশনটা পড়বো, তখন আমরা এটা করব ইনশাআল্লাহ। ওকে?
ওকে।
P equal to 2 by root over L by G, এটা একটু কেউ মনে রাখো, ওকে? যে মানে আমরা এটা সামনে শিখবো এবং তখন করব ইনশাআল্লাহ। ওকে?
আচ্ছা।
আচ্ছা ঠিক আছে, তো তাইলে I think we are done with the numerical problems and I would like to request Shiham to give the PDF of the creative of this chapter, okay, and you start solving those creatives so that by Sunday inshallah we can discuss about them. Okay, whatever the amount of creative is, try to solve at least half of them because you have got a weekend, right? Okay, so try to solve at least half. If there is 40, then try to solve 20. Okay, and as I always tell you, plan your time. Okay, see that in every day how much you need to do to complete or to reach your desired goal, and work according to that. Inshallah, it will be easier for you. Okay, thank you very much. Assalamu alaikum warahmatullahi wabarakatuh. And if Shiham forgets, somebody kindly remind him to give the PDF. Okay, anybody wants to ask any question before we end the class?
No.
Okay, thank you.